Okay. Am I recording already? Yes, I am. Okay, this is an electric receptacle outlet. This is an outlet. Okay, an outlet box. This is a receptacle. Is the device. And when we install our splashbacks or our backsplashes, anybody gets upset if I don't say it the way they like it, and I understand. Okay, so now it's extended out past this box right here. And so this cover plate doesn't seal the outlet box, so if this sparks and melts down and spits out, all right, well, there's nothing to stop it. There should be a spark suppressor ring in there, or a extender. Sometimes they're called extenders, and sometimes they're called goof rings, because that's what the tradespeople think of them. We don't need those stupid goof rings. So we got these goof rings. We don't have them. And they're about $3 a piece. They're going to charge you sales tax and stuff. That's how they get you. But the moral of the story is there's 3, 6, 9. There's not $20. It's a relatively inexpensive fix to make it right. So that's the moral of the story. Is it wouldn't hardly cost anything to do it right. And so we don't have those. And a lot of our light bulbs or luminaries are inoperable, so we've got that kind of thing going on. This is the main. Okay, our power comes to the home off of this pole above grade, and it comes in, and for 240 volts you might want to call the power company for a line audit. For one thing, all your insulation's breaking off of it. Now the power company probably won't do anything about this, but that's your weather mast, your service head. It's supposed to extend past the roof covering, not underneath it. It's supposed to extend out and above the roof covering. And this cable is supposed to be elevated to that cover a minimum of 3 feet above the roof. So our weather mast, our power supply conduit, okay, see, we like these names. Everything's got a name. Our power supply conduit with our weather head, bellwether head, some people call. And then our insulation's all breaking off of this, and you might want to do a line audit. This house is built in the 1950s, so there's no telling what size. At one time, this was the garage, and there's no telling what size electric service panel was in here originally. But we've updated it, if you will, to 125 amps. We do not have GFCI for the refrigerators. Refrigerator's still a kitchen. Refrigerator's not supposed to be in front of it. You're supposed to have 36 inches of unobstructed workspace in front of the load center. And that can be made, all right, after you disconnect the water. It's going to take something. It's going to take an effort. So coming on in here, and again, no doubt this is not original. Too many good practices available. They didn't used to do that in the 50s. But we're not perfect. It's 125 amps. Most municipalities in this area require a minimum of 150. It was probably okay when it was installed. But think about this for a moment. You've got an electric water heater. You've got electric range. You've got a 4-ton air conditioning system. You got 125 amps. Speaking of air conditioning system, it's 40 amps right there, right? It's supposed to be 40 amps. What do you got? AC, 30 amps. Underfused. In the other video, I said it was overfused, but it's actually underfused, which means this will trip prematurely. And you're going to see a video here in the near future where I say that it's overfused, and read the report, because the report's going to tell you that it's underfused. Okay. We shouldn't have white hots coming in. All right, I get it. The wires are white. It's for 220. We need to do that. All right. So since we're doing that, what amps are you? Give us a clue here. 30, yeah, this is clothes dryer. Alright. So they should be wrapped with black tape. They should be wrapped with black tape. L1 and L2 coming in. Okay, there should be protective covers, non-conducive covers over there. So that's our neutral. And these cables are probably undersized by today's standards. Okay, electrician's going to look at this regardless. And then we got this bus bar over here, and this bus bar over here, and they're joined. And these are all of our neutrals, the white wires. So these are all joined on the same, but they're bonded, but our grounding is not bonded. Well, speaking of grounding, walking around here again. Let me walk around my 36 inches of clear surface space. Come over here. We're supposed to have 2 grounding rods. Okay. And we have one somewhere there. Ah, wait a minute. We do have 2 grounding rods within 6 feet. Our second grounding rod, how about that? Never hurts to look twice. Our second grounding rod should be buried. Okay. It should be buried 8 feet. Not 7 feet. Not 7 feet 4 inches. 8 feet. But we do have 2 grounding rods. That's a good thing. These videos keep me honest. But our grounding and our neutrals are not bonded. They're supposed to be bonded in the cabinet. You know it was bonded because it'd be a big green screw indicating what it's for, and it'd go all the way through one of these, for example. Look at that. Look at that bus bar just shaking on there. I think we need an electrician in here. Please. Okay, so if you don't know this is hot, you don't belong in this cabinet, and I get that. But it should be wrapped with black tape. No big deal. Now, these knockouts right here, you got an open knockout right there, you got an open knockout right here, you got wires coming in, open knockout, you got an open knockout up here, you got wires coming in out of that. No, that's not an open knockout, excuse me. It's got a bushing on it. That is an open knockout. Got the wires coming in there. Okay. I know I'm kind of rambling here. Look at the scorch marks on these guys. Man, we've experienced some heat here. We sure have. So we've had a heat event. Might have been, I don't know what it might have been. We've had a heat event. Could have been lightning or not. But for whatever reason, this is stressed more than the manufacturer wanted it. So we're still going towards the electrician here. Now moving further along. This is our cabinet. This is our cover plate. This is called handwriting. It's not supposed to be handwritten. And for that matter, the labeling isn't even correct. So not only is it incorrect, but it's handwritten. It's supposed to be printed like that. So what do we learn? Power coming to the house comes underneath the eave, doesn't go over the roof. Insulation's torn on our power cables. Probably want to do a line audit. Our second grounding rod is not properly buried. We have insufficient service clearance in front of the electric load center. It's hand labeled. We got open knockouts, unprotected conductors entering the cabinet, undersized condensing unit. The water heater and the range do not have lockouts. The clothes dryer is not GFCI protected. We got some white hots that need some black tape on them. I cannot ascertain, I cannot determine that our neutrals are bonded to our grounds. And we've got a loose neutral bus over here, and we've got a heat event that's happened right here. And it's 125 amps.